Test, test. Throw at the presenter.
So, hello everyone. We're now having Alex Schwartz. He's the CEO, founder, and janitor of Alchemy Labs. They mostly work on VR video games, and their most well-known games are Rick and Morty VR and Job Simulator. Agora, por favor, deem uma salva de palmas, que vamos ouvi-lo. Obrigada.
Thank you. All right. Hi, everybody. It's an honor to be here, and I'm glad to be speaking to all of you. And so, yeah, I guess I'm going to start, and hopefully there's time for questions at the end, because I'm going to talk as much as I can about our path through the industry of virtual reality and how we got started as a company. But there's so much to talk about, so I'd love to hear kind of what you're interested in. But like you said, my name is Alex Schwartz. I'm the CEO and also the janitor, which is kind of like a joke title for myself. That when we started the company, when I started the company 8 years ago, you kind of have to do every single role at the company until you hire someone to do that. And so janitor was one of my, starting roles. We're a 22-person company based out of Austin, Texas, in the States. And we have built a number of virtual reality video games over the years. And we actually built iPhone, Android, PC, Mac games before we got into virtual reality. And a lot of those games we built trying very hard to get attention and trying to sell our games on the on Steam and on the app stores to not much success. So it took a very long time for us to get to the point that we found some success in the market. And to that end, recently, about 9 months ago, we were acquired by Google. So we're really excited to be working under a company that really understands where virtual reality is going and can give us the resources and support to continue making original games. So, like was mentioned, one of our most famous games we built is called Job Simulator. It was a launch title on all of the big VR platforms, which when the PlayStation VR hardware launched, we were there as a day one title on the store. With the HTC Vive, that we were packed into the box. So when you bought the Vive at the early days, you got the hardware and you got our game with it, which was really cool. And then with the Oculus Rift, with the touch controllers, we also were there day one when the touch controllers came out. Our game was there. And we followed that up with our next game, Rick and Morty VR, which was we developed it and it was published by Adult Swim, and it was one of the most fun titles I've ever worked on. And we're really proud of that because it was one of my favorite TV shows before we started talking to Adult Swim about it. So it's just an honor to have worked on that. So I guess I want to start by saying, a quick show of hands. Who here has tried virtual reality that has hand interaction? So PlayStation VR, Oculus, or HTC Vive. Who here has tried any of that before? Okay, good. So there's a pretty good number. Maybe that's like 50% of the room has done that. And then maybe anyone who didn't raise their hand, like have you tried something that was like mobile VR or like a headset or headphone or so phone-based VR? Okay, good. So I guess what I want to talk about that we've learned over through developing VR games is that there's kind of a difference in the two camps of VR, and we call the VR that has hand interaction, we call that active VR because that's where we think the magic really is in virtual reality, is to interact with the world with your hands. And I'm going to kind of talk about that. So in Job Simulator, for those who haven't played it, you reach out and you grab and throw and do everything with your hands. So in this game, you can take a stapler and you can throw it at your robot boss. And you can also, reach into the trash can and you could eat a moldy donut and when you eat the donut, you vomit everywhere because it's a moldy donut. You can make coffee in the game. Here's someone making a cup of coffee, and of course we have an accurate liquid simulation that will do color blending and all this kind of craziness, just so that you could pour cream in your coffee and it lightens the color of the coffee itself. So this amazing potential of virtual reality, where you could go to other planets and you could simulate, being across the world with some other human being. We chose to make a silly game about, throwing staplers and drinking coffee. So I guess it's interesting to kind of go through how we got to where we are, which I think hopefully will be like an inspiring tale of a small company that I started in my bedroom, essentially turning into a much larger company. So these are some photos from the earliest days of Alchemy Labs. We did a lot of, we built our first game and we brought it to conferences, and we set up a booth and we printed our own signs, and we dressed up with lab coats and plaid shirts because we made a game about being a lumberjack. So we dressed as lumberjacks, and we dressed as scientists for our first game. And yeah, people didn't really know about our initial development. We tried to get attention, we tried to sell our games, and not many people listened because as you're starting out, it's just pretty difficult to be noticed. There's a video of someone playing on an iPad. And then, if you remember, in 2013, the Oculus Rift Kickstarter happened, and that moment when, essentially some kids were at a lab at a school and came up with this idea for a very cheap virtual reality headset, and then kickstarting it. That, myself and my co-founder, we looked at that and we said, I think there's going to be something really important happening here, that like we're at the start of a new medium. And so we actually dropped everything that we were working on, and we decided to take one of the games we had built previously and bring it to VR just with like a quick port. And so we took a game that we had called which is a game where you jump off a building and you skydive down through buildings. And we made the Oculus Rift version and called it Oculus. And so here it is, in VR. I think if I click this, yeah, you could see people playing the game. And so we learned a ton about how to build a virtual reality game, but this was the earliest days when we didn't really know what was possible. And I would say that we probably learned more how not to build a virtual reality game by doing our first experiments. And but because we were so early in one of the first games that was sold on the market, we got invited to speak at a big conference that Valve puts on called Steam Dev Days. And they invited us to kind of give a talk about, well, what are we learning about virtual reality, what works, what doesn't, what makes you sick, what is comfortable. And at that time, we got invited to go in the back and try out a demo that Valve was working on. And so here's a photo of it, but people refer to it as called the Valve Room. And so what happened, what this hardware was it was a VR headset that used inside-out camera-based tracking. And so those QR codes on the wall, it would see those QR codes and understand its position, the headset's position within the room, and allow you to walk around the entire room in VR. And so that was something that had not existed. You had to sit directly in front of a little camera, and you could maybe move your head an inch or a couple inches to the left or right. But this, you could lay on the floor, you could sit in a chair, you could walk up to all the walls, and it was pretty insane. And so that moment, we realized there's something magical here with the future potential of virtual reality, and we want to do this as our own, like as the only thing we build. Let's stop doing mobile games, let's stop doing PC games, let's only work on virtual reality. And so Valve approached us so if you're familiar with the HTC Vive, it's a headset that's for sale right now out on the market. They said, hey, we're going to build this, but it's a prototype, and do you want to get access to the prototype a year before it's going to be sold, or maybe about a year and a half, and try to build something interesting for it? And so we said, absolutely, that sounds amazing. They weren't going to pay us, but, and so we were kind of running out of money as a company, and so it was a risky thing to do, but we said yes. So at the time, this was the whole company. It was 4 people. This was in, let's see, January of 2015. And we went up to Winnipeg, Manitoba, Canada, to my co-founder's house because we only got one of these little headsets. There's only one. And Valve shipped us this one, and so we all had to meet up in one spot. And I just want to kind of reiterate, like when you try VR today, it's it's a fully packaged product, and you plug it in, and generally it works most of the time. This was 3D printed, and when you touched the photodiodes on the headset in the wrong spot with your finger, you'd get an electrical shock. Like they did something wrong with the power on the headset, and so it would shock you. It was very painful. And then each controller, they're supposed to be wireless controllers. Each controller had 2 separate USB wires running back to the PC. So you had 2 on the left hand, 2 on the right hand, and then 2 on the headset. So you needed 6 USB cables all bundled together. So this like huge bundle of wires, and the whole thing was like barely held together with hot glue. But it worked, and it worked just enough to give us the taste of what could be done in VR and to start prototyping. And so we built this game that ended up becoming Job Simulator, but we spent a week prototyping. And so for those of you that don't know the game's design or like the premise is, it's a future where robots have taken all human jobs. And so humans have no more jobs available, all robots do them now. And so the robots built us a simulator so you could go back in time to relive what it felt like a museum of jobs. Like back in the day, you used to go to an office or work at a convenience store. And so that was the premise for the game. And I guess that's not the kind of idea that just comes out of nowhere. It's a very strange idea to come up with. And so I want to take you through the process of coming up with that and how we emerged with this idea, because I think it's important. So we had this new hardware that no one had ever seen before, and we had no idea what to do with it. And it needs to run at really fast frame rates, so you need to render very quickly. And it's going to be, sold to consumers instead of like VR used to be like an academic product only. It would be like $1 million per headset, and you'd see it only at a big university, and it would be for research purposes. And now it's going to be cheap. It's going to be like in a store, or you could buy it on Amazon or wherever. And so this was this big opportunity. And so we got the hardware, and we unboxed it, and we plugged it in, and we thought, okay, now we're going to play or test the stuff that, like the demos that they give us for the hardware. They gave us nothing. We had no demo, we had no sample project, we had nothing to even try. And so what we did is we opened up Unity, which is the video game development engine that we use. I don't know, how many people here are familiar with the concept of the Unity game engine? Okay, yeah, cool. So we opened it up, and you have an empty scene, and you're just standing there in an empty black room. And so the first thing we did was we made a table at about waist height. Because again, you're standing up in VR, and we're testing this out, and so reaching down to the ground was kind of annoying. So we said, okay, let's just build a quick table out of boxes, and then put 3 cubes on the table. And the first thing we tried to do when we were coding it was, let's make it so I could pick up the boxes with our hands. And so right when we did that, we found out, and you add physics to each box, and then we found ourselves sitting on the floor making stacks of boxes and then knocking them over and like laughing and giggling and throwing items and like balancing blocks on like a stack of blocks on our hand and trying to keep it from falling over. And here's a picture actually of the prototype and Devin. He's sitting on the floor. I wish I had a video of it, but we were just giggling. Like we were a bunch of adults laughing about knocking blocks over in virtual reality. It was a pretty incredible experience. And here's a quick video, I think, of me. We're just testing out the idea of using physics in VR. And so we built a little kitchen, and I have a knife you could pick up. And I think I pick up a frying pan, and I put an egg in the frying pan. And then again, I didn't code any of this to do anything specifically, but it just, when you have good physics, I was able to flip the egg and catch it. And so it's like emergent behavior that you just add a rigid body and you model something and you just see what happens. And we were having fun with no real coding, I guess. Like, we didn't try to code that. It just happened. It just worked because of physics. So the idea was, let's make a video game where you use physics with your hands. That's all we knew. And so we started to think, what places in life have lots of things to pick up? And like, what areas could we build, what levels? And we thought, well, a kitchen would be good, because a kitchen's got like utensils and food items. And then we thought, well, maybe like an office. If you're at an office, you've got things on your desk, staplers and blah, blah, blah. Convenience store, maybe you check out, there's like items, and maybe a mechanic shop where you have a car parts or something. And then we realized all of those things, all those places, you as a player are the, like, you're working. And so these are all jobs, you're like working jobs. And so I opened a Google document and I wrote as a joke the name of like the project we were working on, called it Job Simulator. And then we never changed the name, and that was the game name that we shipped with. So it stuck. But anyway, the thing that we didn't expect was that there's magic that happens with your hand interactions when you get accurately tracked hands. So I guess to explain that is that when you see something in VR that represents where your hand is located, and it's so smoothly tracked at a good frame rate and it's properly working, your brain doesn't interpret it as like an element in the game. It interprets it as your own physical hand. So I think what happens is that something clicks deep down in your brain, and it's this like whoa moment where magic is unlocked. And I guess some examples is that, like, we've been trained all our lives to be able to do natural hand interactions, like reaching out and picking up something, because that's just how life works. And so I guess if if someone threw a ball at your face, you would block your face instinctively to protect yourself. And like this dad here, just if something quickly comes flying at you, your reflexes take over and you try to catch that cake that's about to fall on the ground. And so that kind of stuff happens in VR. I guess I have a couple other funny examples of protecting. Oh, that was close. One more. This is like a dad save moment right here. Instincts kick in. Oh. And so in VR, the skills that you have with your hands just carry over one-to-one. So here is in Job Simulator, someone picks up this item. It's a potato battery. And do you see there's like a basketball hoop, trash can in the background? If you were able to make that throw in real life, maybe from 10 feet away to a bucket that has like, I should use meters, 3 meters away, and a small opening. Like, if you could have the accuracy to make that throw in real life, it would work in VR. So here's a video of me. I've been juggling most of my life, and so in VR, I have a video of me juggling tomatoes in the kitchen. And again, we didn't code anything to make that happen. It's just because your hands are accurately tracked and it just works. And I think that what's interesting is that in video games, forever, you've had a controller, and the controller is to control an avatar. And when you hit a button, like the B button, it will make the player jump or crouch or whatever. And now you don't have to do that. You don't have to use abstractions, like one layer removed from the actual action. You actually can do it. So to reach down in VR, you actually just bend over and reach down with your actual body. And so it's like all of the mappings that we used to have for all the different actions you could have done in a game now can just be simulated via just motion. And so instead of making a bunch of buttons for that like lever right there, where in the video they pulled a switch, now we can just do all that, and I'm turning a knob here to the blender, and now the blender is going to come out. All of this is kind of spatial interactions. And so that means that we don't have to, well, the games and interactions in VR can be more accessible because we don't have to have someone learning how to use a controller. They can just do what's natural in real life. And you know, also in VR, you could see this character. I can really sense the emotion and how excited that character is while they're playing. I guess you could tell in social VR when your friend is playing with you that that's them because of the body language. And there's all these other magical things about VR, like scale and depth and presence and emotional connection with characters in VR is just so great. But I guess I'm not going to talk about that too much. I want to talk about some of the little moments that make VR magical, like black magic. And so the first one is pretty funny. It's a couple stories. So in Job Simulator, you can eat items. You could eat food by picking it up and putting it in your face, and then the character eats it. And there's donuts as the first thing that you eat in the office. And if you ever see anyone play Job Simulator, watch their mouth in real life while they're doing that. Everyone opens their actual mouth to eat, even though clearly you don't have to do that in the video game. And it's just something deep down that like our brain accepts that this is close enough, this is real, and so I need to open my mouth because otherwise I'm gonna hit the food into my lips. People get so comfortable with VR and the space that they're in. There's a thing called proprioception. Proprioception is understanding where your limbs are in 3D space. So proprioception is what allows you to close your eyes and touch your own nose without needing to see where your hand is, unless you're drunk, I guess. But we see people in VR, there's like a cabinet and they want to close the cabinet. And when they first start learning how to do it, they grab it and they look at it and they close the cabinet. But imagine you're in your kitchen and you're trying to make something really fast. Sometimes you go like this. You look away from where your hand is situated and just kind of close it. I've seen people try to kick a door closed in the game, but there's no foot tracking. Like clearly that's not going to work, but they're so sold that this is a real world that they're inside of. It just shows how much your brain can accept this. Here's a good one. So in the kitchen, in Job Simulator, you can break wine bottles. You can smash glass on the ground. And so my friend was playing. Let's see if I can like keep that shown. Yeah. My friend was playing and she broke some glass on the ground. And it turned out she was playing the game while wearing socks on a rug indoors. And for the rest of her play session, she kept tiptoeing around the pile of glass because it was like, oh, I'm going to cut my feet on this glass that exists, but there's nothing there. Same with, there's an app called Tilt Brush. Again, like if you haven't tried some of this high-end VR, Tilt Brush allows you to paint in 3D space magically using your controllers. And so my friends and I were collaboratively painting something in the living room, and we built this big drawing that became this big mess of like trees and stuff. And the whole room became full with like 3D art. And so we put the headset on someone to show them what it looked like, and they were trying to walk around all the art, and so they were like kind of like up against the wall trying to sneak around it. But imagine looking at this person in real life. There's a big empty room, there's nothing in their way, yet they're trying to like sneak around the edge of the room just to not touch the fake 3D items that don't actually exist. So this is another interesting thing about VR is that when you give people tracking and you can move your hands and your body, you become embodied in the character that you represent. So, and people are silly and fun and have a lot of fun in VR. And so this is a video of Batman on PlayStation VR. Early in the game, you get to this, it's like very somber, serious moment. You get to put on the mask of Batman, and you see this mirror right in front of you, and it's you, like being represented in, in real time. and the music's very dark and serious, and it's supposed to be really serious. But what everyone does, I see everyone do the same thing. They realize their hands work, and then they start being really, really silly. It's super dark on the projector. I don't know if you could tell, but there's a lot of dancing and yeah. So the other thing that we've noticed in development is that a lot of VR games end up training the user incorrectly, training the player incorrectly through interactions. And I guess there's a phenomenon that I've noticed called interaction disappointment. I'll explain what it is, but it really must be avoided at all costs. So imagine any game that used to be made for PC or a console. Here's a level from a video game, just a regular video game, right? There's a room, there's a bed, there's a dresser, there's a table on the left that looks like it's got some papers on it, maybe some food, as a bread or something, and then a coffee mug. And so the artist who made this level clearly said, okay, well, what would be in a normal bedroom, and I'll just fill it with items. And so this level designer made a bunch of props and put them and filled out the space to make it feel right. But if you're in VR and you go into this world, you're going to walk up to that table and you're going to want to reach out and grab that mug. And if you can't grab that mug because it's stuck to the table and the designers didn't think, oh, we need to make this mug like an independent object on its own, then it feels like if you take a toy and dangle it over a baby, and then they really want to grab it, but you keep it just out of reach. And that baby's going to start crying because really wants that toy, but it's just like that in the video game. You're like, I really want to grab this thing, but it doesn't let you. And so, it really bums you out. Like your inner child gets sad from that. And so everything that looks like, if you're designing a VR game, anything that looks like it could be interacted with has to be interactable, or otherwise, it's disappointing. But the other thing is, it also has to be right. It has to be correct. And so the example that I use, this is really difficult as a VR developer to have to deal with this, is that let's say you went in that level, in that example with the cup, and you made the cup pick-upable, and now you have a cup, and I'm holding it. The next thing you're going to want to do is find some source of running water or a sink, and to be able to turn on the sink and then put the cup under the water in the sink and then fill the cup up and then try to like slosh the water around and then pour it. And so there's all these thoughts about how a cup works that are in your head. It's like the worldview of how you think cups work. And if the game doesn't uphold that worldview, again, it's disappointing. And so that means as a VR developer, you start having to develop everything, like you're almost simulating the entire universe to allow people to feel like the world functions as it should. So here's a couple examples of that we learned during the development of Job Simulator. So there's plates. There were plates that we put in the kitchen on the counter, and that seemed like a good idea. And I remember my friend was playtesting in the early days, and she picked up a plate, and then she threw it on the ground, and the plate just landed on the ground. And it didn't break. And she went, "This is the worst game ever." And so it's just that one little thing that didn't, you expect a plate to smash in real life, and it didn't. So the next thing we did, of course, was to add smashing plates into the game, because it was so important for people to feel like the world is upholding the standards of, the world. Here's another one. There's robots in the game, and we started putting like glasses on them just for a costume, and it seemed visually fun. But then people started reaching out, because they were 3D glasses, like they had dimension. People would reach out and try to grab the glasses off of the robots, and then we said, so they tried a couple times and it wouldn't let them, and then they gave up. So we said, okay, let's make it so you could pull the glasses off of the characters. And then the next thing people did is they tried to put that on their own face, and they wanted to wear glasses. And then it just kind of, we had to do that. So you made it so that you could pick up glasses, and then you could wear the glasses. And then we added hats to characters, and then people wanted to take the hat off and wear their own hat. And so it led to, like, playtesting led to the creation of our hat and glasses system in the game because everyone wanted to try to do it. And then the last thing was obviously the coffee. All the liquid was just this crazy system that was really complicated to build, only because people expected it to pour properly, and they expected the color of putting cream in their coffee to make the coffee lighter. And so, like, we ended up making a physics-based liquid system and coding it. It was like a really, really complicated academic problem, and it has to run at 90 frames a second, and the whole physics liquid system had to run at under 1 millisecond of our 11 millisecond budget. And yeah, it was pretty nuts. And then we added a task about making tea in the kitchen, and we found, so I'll go into it. The idea was to make tea. You have a tea bag, and if you put the tea bag in water that is hot, tea gets, like, it changes all the liquid that was water into tea. That was how the system would work. So a couple things we didn't think about is that some people microwave a cup of water to make hot water. And so we needed the microwave to increase the liquid temperature of the water to support everyone's thoughts. We also needed, like, some people put the ceramic cup on the stove and turn the stove on. And then after the water was, or no, they put the bag in an empty cup, and then turned it on and then added water. And so, like, we needed to start tracking per milliliter of water its own temperature so that we could build the system properly, because that's how it needed to work. Otherwise, people thought the game was broken if it didn't do what they hoped. Yeah, there was another one where, let's see if this works. There was a robber who comes in the convenience store and tries to rob you with a banana. And so people tried to reach out and grab the banana gun, and then we had to make it, like, grow a new one. That was our solution. And so every time you do that, it says, like, a joke, like a voice line. And so we just had to keep going down this path of trying to support what people were doing in the game. Here's an example of something that didn't work at all. We wanted to have knives in the game, and so if you think about it, a kitchen should have a knife to cut things. But here's what everyone did when they grabbed a knife in the game. So in that video, I think we coded it to actually cut apart the objects. So that means that every time you cut an object, it splits into 2 independent objects, and then you subcut those 2, and then it turns into 4. And so you end up with, like, 40 or 50 tiny slivers of active physics items that are all interlocking and shaking, and the physics system can't handle it, and it would lag the game to the point where it would crash if you cut too many things. And so we thought, well, we can't allow the knife to cut that many times. We have to somehow fix it. And so we came up with this terrible idea. We're like, what if the knife broke when you cut something? So it was like disposable knives that only work once. That didn't work. And then we tried to make a knife that would comically avoid items. It was really weird, and it didn't work at all. So we gave up on that, and we had to cut the knife from the game. We had to remove the knife from the game completely because we couldn't get the expectations of what people thought knives should do correctly in the amount of time that we had. We also had this thing in Rick and Morty where, well, in VR, so you're in Rick's garage, and clearly there's a door from the garage into the rest of the house. And so if you have that door there, and it's in the show, we can't remove the door, but if the door is there and there's a doorknob, people want to reach out and grab the doorknob, and they expect the door to open, and then you're going to be able to, like, walk into the living room and into the kitchen and outside and, like, have infinite. There was no way we could model all of that. And so what we did is we made a joke, and when you reach for the doorknob, it comes off and it just says real fake doors, which if you've seen Rick and Morty, is a joke from that episode. And so, yeah, there's a couple things you could do in VR games that start messing with the players' minds in a bad way, where, do you know the idea of like pointing at something that's far away and trying to get it, like a force grab, like from Star Wars or, you know, something like that? We found that if you add that to your game, so here's a video of that. You just reach, and then you point, and then you click, and it just kind of comes to your hand. Can I just play it again? So that seems cool, right? Like, I could reach something really far away by using this mechanic. But the thing is, you stop wanting to move around and actually, like, physically reach for something. So even though it's, like, you know, a couple centimeters away, you just start being lazy, and you just go like this, and it just kind of comes to you. So how many of you have played Wii Bowling before? Yeah. So have you ever noticed that when people start playing Wii Bowling, they're like really into it, and they do like the full motion of like the whole act of bowling, and then like an hour into it, you're just kind of like going like that. And so we didn't want that to happen in our game. It's like VR you can avoid the shortcut that the Wii, you know, the Wii has an accelerometer in the controller, and it doesn't really know where it is in the world. It just knows rotation. So you can kind of trick it. But in Job Simulator, what we did is we arranged the levels so that you see the door on the right is where you can get some items, and then the plate on the left is where you place the final item. And those are just far enough apart that you physically have to walk from one side of your area to the other. So there's no shortcut. There's no way to not move. And so we thought of that and wanted it to be like a physical, active game versus that like Wii Bowling shortcut stuff. I guess there's a couple other things that are interesting about VR that people don't necessarily think of. One is that in the real world, when you move your hand into something that exists, your hand stops, right? Like there's something stopping me, and the skin of my hand hits against this wood, and I feel that feedback, the haptic feedback. And in VR, there's the table. If you make a virtual table, there's nothing there. So you just go right through it. And so it's really difficult to try to make a table feel real. So what you could, like, one thing you might think was, what if I just make it so that the virtual hand stops at the table, but then my real hand goes through the table, but then you've got this like your hand gets disassociated from the visual, and it's not good. And so what we did, let's go back. What we did is we made it so that items in your hand have permanent physics, and that your hand is kind of ghosts through things. So notice the tomato stops on the table, and it actually has a joint in the physics system connecting my hand to the tomato, and then when I move through the table, it breaks the physics joint and allows it to stay, whereas my hand, there's nothing I could do to stop my hand from moving. And so that makes people feel like this world is so real that we've actually seen people lean on a non-existent table and just fall over in real world because they think it's real. I've even had people drop their controllers. I've done it myself, actually. It is that the table right there in VR, I would like put my controller down, but there's nothing there, and it hits the ground. The other thing is that we did some work with haptics. So like the little rumble inside of the controller, you could use that to simulate the feeling of real interaction. So when I pull that lever to make a slushie, what we do is for every degree that you start to rotate the lever, we do a click in the controller, and so you get the feeling of like friction in the controller kind of rumbling as you do it, and it adds another layer in your brain of thinking that this is all real. People ask us, how do we like come up with the designs of little things in our games? We actually spent some time walking through toy store aisles and looking at how kids' toys are built, because there's something interesting about the fact that in VR your hands are like not as articulate as they are in real life. Like in real life I have all my 5 digits and I can do like intricate little motions. But think about a blender. Most blenders have like 10 little buttons at the bottom, and you've got this big controller and like a big glove hand. How are you going to hit 10 small buttons? So we built a completely different blender that would never exist in real life, which is it has like this arm, like a slot machine arm, and so you pull it down. And so I guess it was all designed for, if you think about your hand as just one mitt, like the joke from The Simpsons about your fingers are too fat to hit the buttons. And, that it was just, that's how you have to think about it. You have to design it in a different way than how real life really works. Same with a menu. So in every video game you've ever played, when you like start up a game, you've got a menu. It's like play, options, quit, or save, game save. And it's a 2D flat menu with options. That's not a thing that exists in real life. It's like a construct we came up with for video games. And so we needed that for our game, but we're in a 3D world. How do we, and in VR, do we just make a big flat plane somewhere and then use a laser pointer to like pick the option? And so we thought that would be like a disappointment, is to use the idea from how we've always built games and put that in the real world of VR. So we thought, how do we use in-world interactions to do a menu? And so we thought, well, what do you do in the game? You can like move your hand around in some weird way. Maybe if we put a bell somewhere and you hit the bell, and that would like bring up the menu or whatever it is. And or maybe there's like a sign, like a target somewhere, and you have to throw an item at the target, and when you hit it, it would like quit the game or something. And so we tried prototyping this idea of like a multi-tool that had like knobs and dials and things on it, like a Bop It, if anyone remembers that weird toy. It didn't really work, but what we ended up with is we realized that eating is a verb that you do in the game a lot, and so we thought, what if you ate the choice you wanted to make? So we made this thing called the Exit Burrito, and so I'll show you a video. You get a suitcase that has a burrito that says exit on it, and you eat it, and then if you eat the second half of it, it brings you back to the menu. And so that's how we did it. It's just a very weird thing, and people were very excited about this because it's just such a weird but memorable way to do something extremely different and try not to use the prior designs of how video games always used to be made, again in VR. So we also, I don't want to spend too much time on this, so I'm gonna like fly through it, but the space that we build for each level, here's a picture of like the convenience store. We actually have a medium version and a small version. So there's small, medium, large. And we build each of those manually by hand, and then based on how big your room is in your particular play space, we like load the right one. So if you have a small room, then we'll give you small. We don't make it so that when you open the game, you have to pick, do I want large, medium, or small? We can detect that via a method of detecting it. And so people don't really even know that the game has different sizes. They just know the game works in their house, and it's fun. But sometimes you watch it on YouTube, they watch someone else playing, and you're like, hey, it looks slightly different. Or like that machine, that freezer was in a different spot in my game, and this person sees it differently. It's because we do all that work ahead of time to try to make it easy. The same in Rick's garage in Rick and Morty. So you could see I'm switching between the small right there, and there's the medium. Yeah. And so we remodeled all this stuff and did a lot of work to make it seamless for people. So yeah, it takes a lot of time and effort to do all of this to build for VR, because it's not like building a regular game. You have to like think of, how would I want to do this in a perfect world? But you might run out of time and budget before you can do it the way you want it. So it's kind of a balance. And the thing I see the most is that people think, well, I want to make a game, or I want to make an app, or I want to make something, and I'm going to just try to bring it to VR. Like the idea of, I have a thing, I'll make it work in VR. And I think that's kind of the biggest design problem I see, is that there's a lot of games that came out recently that were like well-known, established things, like Resident Evil, Skyrim, Fallout. They all just took the game that existed and then put the game inside of VR and said, well, there you go, you could look around. But it's not really built from the ground up for VR. And so, yeah, it's really hard to build stuff from the ground up. But I guess a good example is like when mobile games first came out, the idea was, or when like mobile hardware with touchscreens first came on the market, people took what existed and they just threw it on there. So you see there's a picture of like, what is that, Street Fighter? And then there's a virtual joystick on it, or like the idea of virtual buttons, or all of that is just taking the old method of how things worked and just applying it to a new medium. But then after about a year to 2 years, you got really innovative games that use touchscreen hardware to its like strengths. So Tiny Wings, Angry Birds, Flight Control, all those games, you know, someone sat down and said, what would be really fun with a single finger on a touchscreen? And so I think that's what we need to do for VR, is to think, well, what could only be done in VR, rather than like what would be really, you know, cash grab in VR. So the other thing is like, people say it's really hard to move around in VR because I go into Skyrim and then I have to like use a stick to move around or make a teleport button, because I'm trying to move through this space, this huge space, and I only have like a couple feet in my room. And so the thing is, it's really hard to solve that problem, but you're just kind of tacking motion onto a piece of content that wasn't meant for VR. So I've been thinking, you know, hey, we should approach VR like, what would be really cool to do from the ground up, not how do we get old games to work in VR. So yeah, the challenge to developers is like, what new genres could only exist in VR? What new interactions could you only do in virtual reality that you couldn't even do on a phone or on a computer? And then like people who are just playing, you know, I hope that you'll like see the folks who are trying to innovate in VR and do new things, because it's very difficult to do, and so to support them by buying their content is definitely the way to go. But yeah, I mean, I guess the final thing is like, it's hard to argue if you like skip forward 5-10 years, like the things that you'll remember, the content that will be lauded as like the best in class will all be stuff that you could not have done anywhere else but in virtual reality. So yeah, that is my thesis on that. So thank you, and I would be open to hearing any questions about anything about how the company was started, virtual reality, or life at Google, anything like that. So I know that we have another microphone, maybe, possibly, that we could pass around. If not, you could just yell loudly. I think you were in the front first to ask. And then how much time, by the way, do we have? 10 minutes? Okay.
Okay. Hi. Just to know how many time can our eyes handle with the glasses? Playing.
Oh, okay. Yeah, I mean, some people have said that if you like have a VR headset on too long, it might hurt your eyes. Is that kind of what you're referring to? They haven't really had any good studies about whether it is bad for your eyes, but I think the people who will start to notice whether it's like hurting them are probably the developers who like, because I spend like half of my day putting on a VR headset and taking it off, and that's been 4 years now of doing that. And my eyesight hasn't gotten any worse. I mean, it hasn't gotten any better, but yeah, I don't actually think they have minimum age requirements where it's like you shouldn't be under 7 years old and doing like wearing a VR headset because your eyes are smaller and still developing. But I think for adults, I don't think there's any like safety risk of any kind.
Thank you.
Yeah.
Hello. Why did you choose Unity engine to build your games instead of, for example, Unreal, which is usually considered superior for 3D modeling?
So yeah, when you're building games, you always have an option of using a pre-established game engine, Unreal, Unity, or writing your own game engine. So when we started back in 2010, Unity was really new, and we started using that because it was the fastest thing we could use to prototype in. And so we've noticed that in virtual reality, you don't know whether something's going to work or not work until you prototype it and then try it like with the headset on and using your hands. So my thought is you want to use whatever tool you're most comfortable with that gets you to a prototype phase as fast as humanly possible. And so for us, because we had been building in Unity before, we thought let's just keep using that because we could build quicker. And also Unreal's a bit more render heavy. To render the same scene, it takes a slightly more milliseconds generally because there's lots of like really visually awesome post effects and cool rendering tricks. But in VR, your number one importance is speed of rendering, because if you ever drop the frame rate, then the user will be sick. So frame rate has to be like your top bar. So good games have been done in Unreal, and good games for VR have been done in Unity, like in both. So I think it just comes down to what you're trained in and what you're comfortable with. Yeah, usually bigger teams are using Unreal, and since we started as a small team, we were using Unity, but it's kind of open to your preference.
All right, thank you.
It's more of a technical question. How does the weight of objects play into the virtual reality? For example, picking up a TV would be a lot harder than picking up a tomato. Would that change anything?
Yes, that is like one of the most important things when we think about designing a virtual VR world is that we have this test in our head is it bigger than a cereal box? If it is, we try not to make it something you can pick up, because it's always there's nothing I can do to stop my hand from moving in free open space. So imagine you had a really big, like a broadsword, like a 6-foot massive metal sword, and you want it to feel like you're picking up this huge thing. It's just gonna feel like cardboard or like styrofoam, because you're just gonna be able to move it as fast as you want. So the bigger the object, the more discrepancy you have between like the real world weight and the weight that you feel in your brain. So we try to keep to small items, and that was part of our design is like, well, what areas have lots of small items around you? And that's why it was like an office or a kitchen. And that's why we don't have the frying pan in the end, because the frying pan was really big and it didn't feel right. We had a rolling pin, like a big rolling pin, and then we got rid of that too because it was too big. The only thing I've seen to help with like weight perception is to add a spring follow joint to the item so that when you pick it up, it kind of doesn't move at exactly the same speed as you're moving, so it kind of lags behind. But that can make it feel like a rubber band, so you have to be really careful about how you do that. But I've seen games use that effectively, so that's always an option. But until we could do something magical, or like not magical, it's amazing engineering. Until we could do something that like can dynamically adjust some haptic forces on you, or something that could stop your like muscles from moving in a certain way, we're going to be under the constraint of like open air. Like our arms can move wherever they want at whatever speed they want. So heavy objects are always going to kind of be bad until maybe 10 years from now when we solve it.
Have you thought about changing to augmented reality, or do you think like virtual reality has more future prospects? Or
That's a good question. I mean, there's a lot of talk about what AR can do, and so for Alchemy right now, well, for as long as we've been in virtual reality, we've thought that hand interaction is the key, to making like a magical interactive experience. And so in AR and in augmented reality right now, there's really no hand input, and so we haven't gotten past that. It's just visuals, right? So there's some interesting like data overlay type, like if I want to give someone directions or have kind of like call out information for maybe training purposes, I think AR might be superior in certain ways for training and things like that. But when it comes to entertainment and interaction, there's really just no hand interaction happening at this stage. So we've been seeing that AR is kind of maybe like 4 to 5 years behind as far as like where the hardware technology is. So VR is going to need like a bigger headset and to block out the view, and it needs a high-end PC to run. But we'll get to that level in a number of years with AR, and so then once we have something like that, we'll probably be making AR games at that point. But really the key factor is, do you have hands or not? And so if it doesn't have hands, we just don't work with it yet.
Does anyone have another question?
That's it?
Yeah.
Yeah? Okay. Thank you very much, everyone, for being here. We're now going to do the lottery for the Beats Fund. We're going to make the number generator at random.
Random.org.
Yeah, of course. Does everyone have the piece of paper for the award?
Oh, it's not showing up on the screen. All right. So I'm going to generate a random number between 1 and 54 for the winner. All right. Ready? We do like a drum roll on like... $23 was... Nice. You won some Beats headphones. Congratulations. There you go. Yeah, it's great. Thank you. Yeah.
So, thank you very much. Mais uma salva de aplausos, por favor. Obrigada por terem cá estado. Agora, se quiserem, tem um pequeno coffee break para comer qualquer coisa. Ah, isso é automático?